Hello everyone, welcome back to my channel. Today we are diving into one of the most fundamental concepts in networking, which is the OSI model. So let's get started and break it down layer by layer. So before we get into the layers, let's quickly talk about what the OSI model is. OSI stands for Open Systems Interconnection, and it's a conceptual framework that standardizes how different network protocols communicate. This model is divided into 7 layers, and each layer has its own job in the process of sending and receiving data over a network. The OSI model describes 7 layers of computers that use systems to communicate over a network. It was the first standard model for network communications adopted by all major computer and telecommunication companies in the early 1980s. The modern internet is not based on OSI but on the simpler TCP/IP model. So here TCP/IP is Transfer Control Protocol and Internet Protocol. However, the OSI 7-layer model is still widely used as it helps visualize and communicate how networks operate and help isolate and troubleshoot networking problems. OSI was introduced in 1983 by representatives of the major computer and telecom companies and was adopted by ISO as an international standard in 1984. Let's take a look at the model where the 7 layers are shown. So the 7th layer is, we will start from the top. So 7th layer is application layer, which is human computer interaction layer where applications can access the network services. 6th layer is the presentation layer. This ensures that data is in a usable format and where data encryption occurs. 5th layer is the session layer, maintains connections and is responsible for controlling ports and sessions. 4th layer is the transport layer, which transmits data using transmission protocols including TCP and UDP. 3rd is the network layer, which decides which physical path the data will take. 2nd is the data link layer, which defines the format of data on the network. And the top layer, the first layer, is the physical layer, which transmits raw bit stream over the physical medium. So we'll describe the OSI layers top down from the application layer that directly serves the end user down to the physical layer. So let's take a look at the 7th layer of the OSI model, which is application layer. The application layer is used by end user software such as web browsers and email clients. It provides protocols that allow software to send and receive information and present meaningful data to users. A few examples of application layer protocols are HTTP, which is Hypertext Transfer Protocol, FTP, which is File Transfer Protocol, POP, Post Office Protocol, SMTP, Simple Mail Transfer Protocol, and DNS, which is Domain Name System. Next, we'll take a look at the presentation layer. The presentation layer prepares the data for the application layer. It defines how two devices should encode, encrypt, and compress data so it is received correctly on the other end. The presentation layer takes any data transmitted by the application layer and prepares it for transmission over the session layer. The 5th layer is session layer. This layer creates communication channels called sessions between devices. It is responsible for opening sessions, ensuring they remain open and functional while data is being transferred, and closing them when communication ends. This session layer can also set checkpoints during a data transfer. And if the session is interrupted, devices can resume data transfer from the last checkpoint. The next layer is transport layer. Transport layer takes data transferred in the session layer and breaks it into segments on the transmitting end. It is responsible for reassembling the segments on the receiving end, turning it back into data that can be used by the session layer. The transport layer carries out flow control, sending data at a rate that matches the connection speed of the receiving device, and error control, checking if data was received incorrectly and if not, requesting it again. The 3rd layer is network layer. Network layer has two main functions. One is breaking up segments into network packets and reassembling the packets on the receiving end. The other is routing packets by discovering the best path across a physical network. The network layer uses network addresses, typically Internet Protocol addresses, to route packets to a destination node. The second layer is data link layer. The data link layer establishes and terminates a connection between two physically connected nodes on a network. It breaks up packets into frames and sends them source to destination. This layer is composed of two parts: LLC, which is logical link control, which identifies network protocols, performs error checkings, and synchronizes frames, and media access control, which is MAC, which uses MAC addresses to connect devices and define permissions to transmit and receive data. The first layer is the physical layer. The physical layer is responsible for the physical cable or wireless connection between network nodes. It defines the connector, the electrical cable or wireless technology connecting the devices, and is responsible for transmission of the raw data, which is simply a series of zeros and ones, while taking care of bit rate control. So as we are done with the layers, now just take a look at the advantages of the OSI model. The OSI model helps users and operators of computer network. So in this we can see that it determines the required hardware and software to build their network, understand and communicate the process followed by components communicating across a network, performing troubleshooting by identifying which network layer is causing an issue and focusing efforts on that particular layer. The OSI model helps network devices manufacturers and networking software vendors such as by creating devices and software that can communicate with the products from any other vendor, allowing them interoperability, define which parts of the network their product should work with, communicate to users at which network layers their product operates, for example, only at the application layer or across the stack. So we will just take a look at OSI versus TCP/IP model. So the TCP/IP model is an older version and OSI model was created by the US Department of Defense. A key difference between the models is that TCP/IP is simpler, collapsing several OSI layers into one. So we'll see what does it mean. So the OSI layers 5, 6, 7 are combined into one application layer in TCP/IP. OSI layers 1 and 2 are combined into one network access layer in TCP/IP. However, TCP/IP does not take any responsibility for sequencing and acknowledgement functions, leaving these to the underlying transport layer. And other key differences is TCP/IP is a functional model designed to solve specific communication problems and which is based on specific standard protocols, whereas OSI is a generic protocol independent model intended to describe all forms of network communication. In TCP/IP, most applications use all the layers, while in OSI, simple applications do not use all the 7 layers. Only the layers 1, 2 and 3 are mandatory to enable any data communication. So we have taken a look at this particular OSI model, advantages of OSI model and the key differences between OSI versus the TCP/IP model. If you like the video, don't forget to hit that like button, subscribe button, and stay updated for more videos, and see you in the next video. Till then, take care, stay safe, and bye.